My name is Fatih and I work for Ericsson, and I am involved in open source, especially with the open source project called Open Platform for Network Functions Virtualization, which deals with integration of open source components. And Yolanda.
I work at Red Hat. I'm an NFV partner engineer. So what I mostly do is help partners, or customers, telcos, in the NFV area with OpenStack integration, like taking all the NFV features and integrating to their products, especially on OpenStack.
So since the beginning of this track, you have been listening to different talks that are mainly talking about different SDN and NFV technologies such as VPP, DPDK, ONAP, and so on. And all these components are developed, integrated, and tested by different open source communities. And they're all doing a great job. And they all try hard to make sure these components work fine. But in open source, there are not many communities that are dealing with integrating of these components, integration of these components. And there was a gap there which needed to be solved. Especially when it comes to network functions virtualization, and if you look at traditional networks, how they are built, it was obvious that the traditional networks are not possible to scale or not possible to build using open technologies, and it wasn't so easy to innovate in that space in traditional networks. And based on these concerns, HCNFV came up with this NFV architecture in 2012, about 5 years ago, to see how the networks can be developed and built up using these new technologies, such as cloud virtualization and lately containers and cloud native. And as we all know, standards do a great job, but sometimes standard work takes a bit longer than some might want it to be. And based on these concerns or thinking, this open source project, Open Platform for Network Functions Virtualization, in short OPNFV, was established around the end of 2014, so it's about 3.5 years ago, to do integration work using these different technologies in parallel to standards work to see if the idea, the architecture works, and at the same time, if the components developed by different open source communities work well together to build this platform up. So basically, the Open Platform for Network Function Virtualization project aims to create a reference platform for NFV using open source components, open source technologies. And this is kind of a challenging because when you look at NFV stack and NFV architecture, you see many different things that, like NFVI itself or compute, or if you go down in your bare metal nodes and you have on top of it you have virtual networks, virtual storage and virtual compute resources there, and then your NFVI you have mono, then you put VNFs on top of it. So it's really a challenging work to bring up this platform using open source components. And since the day one, OPNFV has been trying to do this by bringing different technologies together, such as OpenStack or OVS, DBTK, and lately Kubernetes. And while doing this, OPNFV tried to be a bit on the safe side, meaning that we started with using stable released versions of all these different technologies, components. When it comes to OpenStack, we wait for OpenStack to do their official release. After 6 months, we take that release into OPNFV and try to integrate it with other technologies such as SDN controllers. And it's similar to SDN controllers as well. We have Open Daylight, ONOS, and Open Contrail there, and we take stable official release of SDN controllers as well, and we integrate released version of OpenStack with released version of Open Daylight, for example. And we do this for all the different components we get from open source communities. In SDN space, we have, as I mentioned, Open Daylight, Open Contrail, ONOS. We have virtual switching like OVS and VPP there. We have mono components such as Open Button or lately ONAP. And we take all these components and try to put together and hopefully improve overall quality of all these components for anyone who wants to use these components for different purposes. Now, since we are using stable versions of these components, it is a bit slow to provide this feedback to upstream communities. For example, if you look at our latest release in OPNFV, we did that around October. Let's see if, yeah, we did the release around October, and we used Okata as part of our release. By that time, OpenStack already released Pike. Pike was released around September, and we released OPNFV in October with Okata, so we were at least 6 months late than upstream. And since the point of OPNFV is integrating these components and finding what works and what doesn't from Tycho point of view, when we find problems with these components and how they work together and go back to those communities, it's pretty late already. It's 6+ months. And all the communities we work with, they're pretty helpful and friendly and so on, but if you put yourself in their situation, if someone comes to you after half a year and asks you, okay, we have this problem, how can we fix this? You might have already moved on to another item in your backlog, and you might not have time and interest in fixing that thing. Or maybe that thing might even gone out from your stack, so you might not have any possibility to fix that either. So this speed we have been doing things in OPNFV is kind of became a bit challenging for us, because we are not talking about single community OpenStack. We are talking about more than 10 communities maybe, and if you put all these delays, months of delays together, it's like years of delays when it comes to feedback time we are getting out of our integration efforts. And based on these findings, we started thinking about how we can make things faster and become more relevant to communities we are working with. And then we started talking with Open Daylight community originally, and we said, guys, yeah, we are getting official release from you, but can we get more recent versions of your technology, your component, a bit faster than how we are doing? And they started working on this together with us to enable continuous delivery in their community, so we can do continuous integration in OPNFV. And as one of our friends, Daniel Farrell, says, like, OPNFV can go as fast as slow as of its upstream. So if someone is very slow, we can't be faster than that community because we depend on them. And by using this thinking and using Open Daylight as our first community to go after this continuous delivery idea, we brought up these continuous delivery pipelines from Open Daylight, which basically means that whenever they build something in their CI using their auto-release process from their master branch, it should be possible to get that latest built and tested artifact into OPNFV environment. So we can basically integrate latest and greatest version of Open Daylight into our NFV platform. And that looked very positive, and we started thinking about how we can do the same thing for the other communities we are working with. And as I mentioned many times, we are working with OpenStack as well, and OpenStack is pretty important in NFV reference platform. And we started with OpenStack community saying, okay guys, we want to do what we have been doing with Open Daylight community, and we want to consume the latest and greatest versions of OpenStack from master branch. And based on those conversations, maybe we can go here, let me, yeah. Based on those conversations, we came to a conclusion that, okay, we can find an easy way to get the OpenStack version from trunk. And we started working on this about a year ago, and we now have ability to deploy OpenStack from trunk, which basically means that whatever OpenStack community has been working during this release cycle, in this case it's Queens, we get that version at least, in worst case, in a week later, which basically cuts the feedback time from 6 months to a week, which is a great improvement. And again, if you look at all these different components in NFV stack, you can see how big difference this could make. Instead of waiting for months for different communities to send fixes to us, we can get those fixes in a week's time, and hopefully later on on a daily basis. And you see all these different things on this slide, and it's really complicated thing to do this work, integrate these components. And obviously we are not doing this manually. We have a CI machinery for OPNFV, and which basically goes through different compositions of the platform, because some of the components can't be collocated together, and some of the components are more people are looking after them, or more people are interested on them. Based on those things, we create different combinations which we call scenarios. And first thing we do is basically we provision our machines with three different Linux, one of the three different Linux distributions, Ubuntu, CentOS, or OpenSUSE, and then we put either OpenStack or Kubernetes on them, and then we put different SDN controllers. Instead of Neutron, for example, we put Open Daylight or ONOS. And then we construct different features like service function chaining or BGP VPN. And finally, once we construct or compose this combination, we run testing against this integrated stack, which is a big difference comparing to OpenStack or Open Daylight or other communities, because they mainly deal with their own components in very small scale. And in our case, we put all these components and try to find what works and what doesn't. And as I said, this is impossible to do manually, and we have a CI machinery for OPNFV, which uses distributed bare metal labs all around the world. And currently it's like, I think, 15 labs they are providing resources, and we have more than 200 bare metal nodes supporting two architectures, x86 and ARM. And as part of our latest release, we had more than 50 scenarios, more than 50 different combinations of components. And we deployed OpenStack more than 8,000 times in 6 months' time, because we continue to try deploying things and try to see if they work. And we start with Open Daylight when it comes to XCI, consuming things from master branches, and then we have been working with OpenStack, which we can deploy both OpenStack and Open Daylight from trunk. And FIDO has been handled in a similar way, but in different scale in OPNFV, because that only dealt with FIDO and OpenStack. In our case, we are dealing with all the components we have, or aiming to deal with, and hopefully we will include ONAP into this as well. And these are CI pipelines. These are upstream project CI pipelines. They all have their patch set verification, daily master jobs, and so on. And we continue to track the master branches to find working versions. And once we find working versions on them, we pin those versions in OPNFV repos, and then create the scenarios using those pinned versions and run testing against them on bare metal nodes.
Yeah. Okay, so now I'm going to talk a bit about the tooling that we are using for that. So we are having different components here. We have Joule, Bifrost, OpenStack Ansible, and kubespray. So Joule is what we are using for project gating. Oh, no. We are using that for project gating. It means that all the changes that are created in a project, they go through this tool component, and it will pass a set of pipelines to verify that the jobs are working and that are in a good state to be merged. So one Joule is doing all the jobs. They pass through the gate pipeline, that is the one that is used for merging, passes a lot of checks there, and after that it goes and merges into the code, and you can trigger another set of jobs to do the package building or publishing or whatever. And then we are using Bifrost, that is used for hardware provisioning. So if you have a set of bare metal servers or VMs, we are going to use Bifrost. Okay. So Bifrost is just a set of Ansible playbooks to deploy a standalone Ironic. So Ironic is a component of OpenStack that is in charge of provisioning virtual machines or bare metal servers especially. Okay. It is written in Ansible, and it supports like 3 major distros, like it is Ubuntu, CentOS, and OpenSUSE. To use Bifrost, it is very easy to use. It's just installing a set of Ansible playbooks, and you basically have 4 steps. So first one, you need to create an inventory, that is collect all the data from your servers, like the IP address, user, and password you are going to use to connect. You put it on a file. After that, you run the second step, that is installing Bifrost. So it is a set of playbooks that will install Bifrost on your server. And once you have it running, you will do the enroll step. That it means it will collect all the information from your inventory. It will run on your machines, and it will collect info of their machines, like hardware, type of disk, all the information you need to introspect the data. And it will pass to a database. Once you have it stored on the database, is the final step to deploy. So what that deploy means, it means that it will take all the bare metal servers, it will install the operating system that you want there, like you can install CentOS, Ubuntu. Also you can customize the image that you are going to install, so you can add like custom packages or extra configs, extra projects there. So you will have all the servers in the same state, the desired state after that. It will also add you a basic network config, so all the bare metal servers will be accessible in the network the way you choose, and it will also copy SSH keys. So you will have SSH keys that you decide, and you could access the servers with that after it. It is very solid. I mean, it has been used in all OpenStack distros, so all OpenStack that they are using bare metal are mostly using Ionic. And we are running third-party CI tests on it. It means that all the changes that go on Bifrost, that it is an OpenStack project, are gated also against our OPNFV testing. So we validate that any changes in Bifrost is breaking the OPNFV CI setup, so it's really good for that. We can trust in Bifrost. Okay, next step is OpenStack Ansible. It is a tooling for installing OpenStack. Basically, there are several toolings like OOO, but we choose this one because it's easy to customize. It's based on Ansible as well, and it's very, very flexible. You can choose the way you want to deploy OpenStack there. You can use it in containers using LXC, or you can deploy directly on bare metal. It is very, very easy to integrate and very flexible. I mean, you can decide the type of roles you want to include in your deployment. If you want to include Nova, Keystone, HA or not, or even if, especially for OpenFV, you can write your own roles. So you can decide, I need to put any extra layer on top of OpenStack. Okay? It also has several ways of deploying, so you can deploy on developer mode and production with HA, with NFS. You can complicate it as much as you want. And then we support also major distros like Ubuntu, CentOS, and OpenSUSE as well. Okay, so final one. Use kubespray. So we started also to work a bit on Kubernetes. So we are starting to use kubespray. So it is a set of Ansible tool playbooks again to install a Kubernetes cluster that is created inside Kubernetes community. It can be created on multiple platforms. You can deploy on, for example, you can deploy on bare metal virtual machines like with Ansible, or there is also possibility to do it on OpenStack, on Amazon, so it's quite flexible for that. It's also very composable, so you can decide the kind, for example, the kind of network plugin you want to bring. You can have different options there. It's supporting CoreOS, Ubuntu, Debian, CentOS, so you have flexibility there. And it's solid because it has like end-to-end integration testing, like performed on different platforms as well, so it's reliable. And well, we are starting to do it as a proof of concept. So we have mostly OpenStack done there, but we're starting to get Kubernetes integrated into OpenFV as well. Okay, so I think mostly well, if you have, let's give 5 minutes for questions.
Before we move to questions, I want to highlight now, we talked about NFV, SDN, and tooling and CI and stuff here. The main thing we are trying to achieve is basically to increase the awareness in open source communities when it comes to integrating all these components together and creating a platform. Because some communities are pretty good when it comes to continuous delivery and DevOps stuff, but some communities are just starting now. And based on what we have been trying to do, the different communities started understanding what we are trying to do, and I think first time in CI/CD space, many different communities coming together to have a workshop during OMS to talk about these things, to see how we can establish continuous delivery way of working in open source. So it is more than just what we talk about here. It is about a cultural, social change. Now we can take 1 or 2 questions maybe.
So would you be interested in CI integration with ONOS?
We have been trying to reach out to ONOS, and I suppose we have done that right now, yeah? We can start talking now. Yeah, ONOS was part of OPNFV like 1 or 2 releases ago, and then they disappeared, and we want them to come back. So we are interested.
One last question. Just say it and I'll repeat the question.
Are all your pipelines fully automated, or do they require some interaction if they fail or if they're destructive in any way?
So are all the pipelines fully automated, or is there some human interaction needed for failures? Or
All the deployment and testing are done automatically, but we are running more extensive testing comparing to other communities.
no, you need the mic.
Yeah, all our deployment and testing are automated, but since we are running quite complicated testing, sometimes it requires human intervention to see what went wrong and reproduce issue and find the problem.
Okay, no more time. Thank you very much, Fatih and Yolanda. Our next presentation is from Emma Foley, who's going to present the Barometer project, which is an OPNFV project for collection of platform metrics and telemetry. We've been having some AV issues, Emma.